Hello, and welcome to Nickel 100, Triton Consulting Services Introduction to the Nickel Industry. Over the next 10 minutes, I'll be giving a high-level introduction to nickel production, including supply and demand and ore types and processing, and environmental, social, and governance, or ESG issues. New nickel production was about 2.5 million tons per year in 2020 and is growing. Some believe that 3 million tons will be produced in 2022. This is supplemented by a significant but variable amount of stainless steel scrap recycle, recovering additional nickel values. Of the growth in the market over the last several years, most of it has been in Class 2 or impure nickel products, the iron nickel alloys, ferronickel, and nickel pig iron. And today, Class 1 or pure nickel products make up less than 50% of the market share. The major market players today include Asian iron nickel alloy producers, which have been the growth story of the last decade, and the Western multinationals who produce most of the pure nickel products and now play a smaller role than they used to. The majority of nickel is used for stainless steel today, and for this we don't need pure nickel. The iron nickel alloys are great sources of two of the metals needed in austenitic stainless steels. Nickel is different than most metals, where only the pure material is used in products, such as copper and aluminum in wiring or zinc for galvanizing. Pure nickel is required for certain high nickel alloys like Hastelloy and for chemical uses, but not for today's dominant use. Although stainless steel is a growing market, the big focus for nickel today is on batteries, where nickel is an essential component of making the highest energy density batteries. Nickel manganese cobalt, nickel cobalt aluminum, and similar cathode formulations are featured in longer range electric vehicles around the world. These battery chemistries require pure nickel products, and the International Energy Agency forecasts that nickel for batteries could be more than 50% of the total nickel demand by 2040. This could mean a 5 times increase in the demand for pure nickel products. Nickel is produced today from sulfide and laterite or oxide ores, and the growth in the last 20 years has been predominantly in these nickel laterite ores. The relative share of nickel sulfide production has been falling, although the absolute value has stayed relatively consistent. Both of these ores contain nickel with iron and other impurities, but they have different levels of byproduct values and occur in different locations around the world. This map shows that most of the nickel laterite deposits, shown by the yellow squares, occur in a belt around the tropical regions of the planet, while most of the nickel sulfides occur in the global north and south. Mining these ores is fundamentally different. Laterite deposits feature fine-grained soil-like ores in thin layers because of the weathering process that created them, so they require large mine areas but are relatively easy to excavate. Sulfide deposits are hard rock deposits which require blasting and typically occur underground or in open pit mines which can be hundreds of meters deep. Processing these ores is fundamentally different as well. Laterite ores are typically processed by smelting, where the entire ore body is dried, chemically reduced at high temperature with a carbon-based reductant such as coal or petroleum coke, and then smelted by melting the entire ore body with electricity to separate out the iron-nickel alloy used in the stainless steel industry. A smaller proportion of these ores is processed by a hydrometallurgical or water-based process called high-pressure acid leaching, where the ore body is dissolved with sulfuric acid at high temperature. The various elements in solution are then separated from each other, eventually producing Class 1 nickel and byproducts such as cobalt. If these laterite ores are not processed at the mine site, the entire ore body is shipped to distant processing sites. Sulfide ores lend themselves to a concentrating process using grinding and froth flotation at the mine site to produce an intermediate nickel concentrate at 10 to 15% nickel. Most of this concentrate is then smelted through a pyrometallurgical smelter using electricity, then refined in a hydrometallurgical nickel refinery to produce Class 1 nickel and byproducts such as copper, cobalt, and platinum group metals. A smaller amount of these concentrates are treated by direct concentrate leaching, where the concentrate is refined in one comprehensive set of hydrometallurgical processes to Class 1 nickel. Most of the growth in the nickel industry has come from the laterite side of the business, where nickel pig iron smelting has been implemented many times quite successfully, but does have high environmental impacts related to the high land clearance and the coal-based electricity used in smelting. There have been relatively few high-pressure acid leach facilities, and many of these have been characterized by difficult startups, where even the best greenfield projects typically take some years to reach design capacity. Very few new large nickel sulfide projects have been built in the last 25 years. On the environment side of ESG, we need to think about a range of different factors. Carbon footprint is important, and we see a range of performance across the industry, where sulfide ores lend themselves to better performance, and the smelting of laterite ores to nickel pig iron has the highest carbon footprint. We need to think about both air and water pollution. Air pollution tends to be sulfur dioxide and NOx emissions from nickel smelters and coal-fired power plants, especially those remote nickel smelters where acid gas capture is not stringent, if done at all. Water pollution includes issues related to mine runoff that might contain pollutants like chromate or selenium, and effluent issues from high-pressure acid leaching facilities. We need to consider ecosystem risks, which depend on the land and pollution impacts of the facility and the ecosystem within which it is located. Tropical islands tend to have the highest risk factors. We need to think about tailings management, both what we're storing and how we're storing it, the dam construction methods. Deep sea tailings disposal is used at some facilities, which can cause different issues than land-based tailings management. And we need to think about where we want to mine. Ocean or land-based mining have very different impact and monitoring scenarios. On the social side of ESG, we have to think about how we achieve and maintain social license for our projects. There's a growing move to NIMBYism in the developed world, where we want the products of resource extraction activities, energy and materials such as new cars, phones, and wiring in our houses, but we don't want the projects themselves. That risks offloading the negative impacts to developing countries where practices may be less stringent. When we think about the developing countries where we work, we need to think about labor and community issues, how we treat the people that work for us, and the people in our surroundings. And of course, we need to look at governance metrics, broadly reflecting accountability for decision making. This map shows the average of 5 of the many different governance metrics, and we see a very wide variation in the performance of major nickel mining countries. Although operations can be operated well in challenging jurisdictions, the risk posed to producers and consumers by unaccountable decision-making and global views of the jurisdictions where they operate is hard to predict and control. Environmental and social issues around a project we want to execute come down to a permitting discussion, where the design of the facility and the situation within which it is located lead to a number of impacts and risks that we seek to mitigate. If we achieve that mitigation in a manner satisfactory to regulators and communities, we can achieve a permit with certain conditions attached. That permit may not lead directly to top-tier performance. How diligently the project and permit conditions are managed, or responsible execution, matters. Ultimately, the whole ESG area comes down to a number of activities that we do and the impacts that they cause. Those impacts are often interrelated in a complex web, and the activities and impacts exist within a wide range of modifying factors that are related to the project location. All of this together is wrapped into the topic we call responsible sourcing. Stainless steel remains a growth area for the nickel industry, but the most exciting growth area is the battery market, which could spur an unprecedented increase in pure nickel production over the next 20 years. There is high interest in responsible production for the batteries used in electric vehicles, but should we not seek similar production standards for all nickel products? We have different ores, different locations, and different processing methods that lead to different types and levels of risks and impacts. The carbon footprint can be an order of magnitude different between the best and worst producers. Air and water pollution levels can be dramatically different. Ecosystem impacts arising from land, air, and water impacts can be substantially different. And of course, tailing management risks and practices vary widely. How we treat people also varies widely. We need to choose our projects and our suppliers carefully when we need to consume nickel. We should be looking to avoid projects with coal-fired power, with high levels of air or water pollution, with high impacts in sensitive ecosystems, and of course, operations in countries with poor governance practices. Thank you for your interest in the nickel business. If you want to know more, Triton Consulting Services is here to help develop the most responsible nickel projects.